I'm Jenna Wiens. I'm a faculty member here in computer science and engineering. I serve as the Associate Director for the AI Lab and as Co-Director for Precision Health at the University of Michigan. And I also head the Machine Learning for Data-Driven Decisions group. This group consists of PhD students in computer science, all studying various aspects of machine learning and AI, inspired by problems in healthcare. We work across a range of different technical directions. Some of these have then evolved into various threads. We do a lot of work in time series analysis and forecasting and patient risk stratification, so trying to predict who's at greatest risk of a bad outcome, of developing a disease or an infection. And then from this, a lot of different research threads have emerged, often inspired by conversations with our clinical collaborators. So early on in our work, clinicians wanted to know why. Why is someone at risk? Why is my patient at high risk or low risk? And this led to a lot of our work in explainability and interpretable AI. Then, once we gave them explainable models or interpretable models, clinicians started asking, how? How do I reduce patient's risk? If I have a high-risk patient, what can I do? And this led to questions in causality and work in machine learning for causal inference and in reinforcement learning in terms of coming up and learning treatment policies. At the same time, a lot of our work in explainability also highlighted a lot of the problems with the models that we were learning related to bias. And that has led to a thread of work on mitigating bias and health disparities, specifically racial disparities in healthcare. In terms of application areas, we work across really the spectrum of clinical care. So from prevention to diagnosis and treatment to even rehabilitation. So we have work in aiming to predict which patients are at greatest risk of progressing from mild cognitive impairment to Alzheimer's disease, or work that helps patients with vestibular deficits or balance disorders perform exercises and trainings that can help restore their balance ability. So in terms of the implications of our work, healthcare globally is strained. And this is especially true in the US, where clinicians are burnt out. Clinicians are spending ever more time studying data about their patients, but still ignoring the vast majority of it. And this is where I think AI can really help. AI can help accelerate clinical workflows and can also help in decision making and augmenting clinical decision making so that the right patient gets the right treatment at the right time. So in terms of what excites me most about our work, it's having real world impact. We are one of the first groups working at the intersection of computer science, AI, and healthcare to integrate AI tools into clinical workflows and observe patient improvements in patient outcomes. And I think that type of real world impact is so exciting. When a clinical collaborator comes to you with a problem and you can you can formalize the problem such that we can then not only advance state-of-the-art in AI, but also advance healthcare. I find that so rewarding. So I love working in a team, and multidisciplinary work, the type of work that we do, requires experts in different areas, and these experts have to come together. I don't think that there's a day that goes by where I don't meet with at least one clinical collaborator and learning from these experts, and then also teaching, so helping my collaborators learn about AI, I really love. So picking one favorite accomplishment is really hard to do, but I can highlight one that is most recent, that's kind of top of mind, and that's integrating a clinical decision support tool based on AI into clinical workflows and then measuring the impact on patient outcomes. And that's really exciting because that's the end goal for a lot of the work that we do. In terms of one of my favorite accomplishments over time, it's been building the team that we have here at Michigan. So in my research group, Machine Learning for Data-Driven Decisions, we have at this moment, I think about 8 PhD students. We've graduated. We have about 6 alums, and it's just wonderful to see them each working independently on their PhD thesis, but supporting one another at the same time. And seeing that culture that they have built, that culture of mentorship and support, I think is just wonderful. A couple of things that you may not know about our group and about some of the work that we've done. So back in 2015, 16, I helped found a nonprofit organization, Machine Learning for Healthcare. We realized that while there was a lot of interesting technical work being done at the intersection of AI and health, clinicians were not nearly as involved as they should have been. At one point, we had a workshop hosted at one of the main machine learning conferences with about 200 people in the room and one clinician. So along with colleagues in this space, we decided to start this nonprofit and host this yearly meeting that aims to bring together researchers doing work in AI and health and clinicians who will use these tools to help frame problems and also solve them. One more thing that you might not know about our group is that in addition to all the work that we do at the intersection of AI and health, we also work in sports analytics. We've done some work in sports analytics, specifically in basketball analytics. So if you want to find out more about machine learning for data-driven decisions, you can search us on Google. If you just search UMich, Machine Learning for Data-Driven Decisions Group, we should come up. We have there on our website information about all of our projects, links to our GitHub, and also links to various videos that the team has done.